and we've just got to power through those. The beginning of the chapter is about motion, movement, something you guys all know about. Okay, and your book starts with a Greek philosopher named Aristotle. Why Aristotle, you might ask? Well, he was the first person who discussed motion. And the ancient Greeks decided that motion required a force. But Aristotle wasn't quite so sure. He classified motion differently. Motion. He said there could be natural motion, which did not require an outward force. Occurs without any force. Okay. Things that he saw as being in natural motion were the planets moving around the sun. Things falling off a tower. Smoke rising from a fire. Aristotle was sure these weren't using any type of force. The other type of motion he talked about was unnatural motion. And this required a force such as a pull or a push. Okay, so that force could be a push, or it could be a pull. So if you're moving a cart, that was unnatural motion because a person was pulling it, or a horse was pulling it, or pushing it. And Aristotle's ideas of motion stayed pretty much the norm until Galileo showed up. Galileo. And Galileo disproved Aristotle by doing experiments. All Aristotle did was think and talk. He was a philosopher. Okay, and Galileo did this very important thing in science. He did experiments. For instance, Aristotle thought that things would fall at different rates. He would compare like a rock to a feather. Well, what he didn't realize is the rock was much denser than a feather, and if you dropped it, it wasn't buffeted around by the atmosphere or by wind the way a feather was. Galileo saw that difference, okay, and he realized it was the difference in the makeup of the rock and the feather that made them fall at different rates. We think of Galileo as dropping things from the Leaning Tower of Pisa, which he did. And he measured how long it took for them to fall. Okay, drop things from the Leaning Tower of Pisa. And another major disapproval for Aristotle's work, another difference, say, is Galileo said that all motion requires a force. Okay, all motion. So when Galileo was saying the planets were moving around the sun, well, let's not go there. When Aristotle was saying things were falling, he wasn't taking into account the force of gravity. With smoke rising, he wasn't taking into account that the small smoke particles were light enough that gravity didn't affect them too much and they were moved about by the wind. Okay? Galileo realized that some force was acting on anything in motion. But what Galileo said that was really important is that a force is needed to make any object move, but once an object is moving, the only force that is needed is one that's strong enough to overcome friction. That says friction. Okay, so we have Aristotle's idea of motion, which he divided into two categories. Galileo did experiments and said, no, motion is all one thing. All motion requires a force, and an object is going to need more force to get it moving, but after that, it doesn't take so much to keep it going. You just have to overcome the friction that wants to hold it in place.